This is the Mutex sample that demonstrates the use of the Mutex class. In this particular demo, we have two classes. We have Program and Bank Account. Let's take a look at Bank Account to show you how a Mutex can be implemented. Notice in this class we have a field called mlock, which is of type Mutex. This will allow us to lock this particular bank account, so when we are transferring funds from one account to another, we can require that both accounts be locked by the same process. Therefore, we don't have to worry about balances changing while we have the lock of both accounts. And then we have a balance, which is going to indicate how much money is in the account. The constructor is pretty straightforward. We pass in a decimal called amount. With that amount, we call the deposit method. Deposit simply checks to make sure that it's a positive value, then it augments balance by that amount. The balance property is set up so you can retrieve the balance externally, but you can only set the balance internally. Withdraw, very similar to balance, makes sure there's enough money in the account to withdraw. So we have the amount passed in. We make sure that, first of all, the amount is positive and that the amount is not greater than the existing balance. If both of those check out okay, we decrease the balance by that amount. Now notice the deposit and the withdrawal methods are both implemented as private methods. In a more realistic environment, these would be made public and they would also participate with the Mutex. But to make this a simpler example, I'm only going to be utilizing the Mutex from within the transfer from method. Transfer from requires an object of type bank account, which indicates the other account which we are going to transfer from, and then the amount we are going to transfer. Now the mutexes can be grouped together into an array, in which I'm calling account locks in this example. So you can see I take the lock from this particular bank account and the bank account that was passed in. So I now have an array of mutex objects which contains the lock of, or the mutex basically, of each of the bank accounts. Then, to wait for all of these mutexes to be locked by this process, we call waitHandle.waitAll, and we pass it that array of account locks. Basically, this will wait indefinitely until this process or this thread now has acquired the locks for both bank accounts. So this allows us to guarantee that when this method runs, we will be able to manipulate the balances of both accounts atomically. So we don't have to worry about anything else interfering with that. Because you don't want the situation where you have two withdrawals occurring at the exact same time, in which case they both do the check to see, yes, the amounts do exist, and then in fact, let's say the balance was $1,000, and both withdrawals are requesting $600. Well, one at a time, they both can acquire $600 out of the account if we're just doing one or the other. Okay, so if they both check to say, hey, is the balance greater than 600? Yes. So they both get the yes. However, the first one that acquires the money or retrieves the money out of the account will get the 600. The other one would cause insufficient funds. So even though the check was valid, by the time the transfer actually occurred, it went invalid. So waiting for both locks in this case allows us to prevent that particular problem. So what we do then is we try to withdraw money from the other account. Now, the reason we put this within the try block is to make sure that we actually have enough money in the other account. So if we go to the withdrawal method again, if there isn't enough money or the amount is invalid, what ends up happening is an exception, argument out of range, is going to be thrown. If that's the case, we simply rethrow that exception. And notice here we're doing it without catching like exception EX we're just saying catch exception of any type and rethrow that exception. This basically then will retain the original throw point information. If we successfully withdrew the amount, we can deposit it into this account. Notice we don't have to put that into a try because amount has already been validated as a positive value. Otherwise, withdrawal would have thrown an exception. So we know the amount that came out of the other account is a positive value, and there's no restrictions onto how much money we can put into an account. If we did have such restrictions, then of course we would have exceptions being thrown out of deposit, and we'd have to put this in a try block. So once the transfer has occurred, we withdrew money out of the other account and we deposit money into this account. Then in a finally block, we release each of the mutex objects. So we say for each mutex M in the account locks, remember that's the array, we say m.release mutex. That allows us then to perform another transfer from a different thread. If we look at program, it's a very simple setup. We have two bank accounts, account 1 and account 2. The first one starts with a balance of $5,000 and the second one starts with a balance of $10. We output the contents of both accounts. Then we transfer $500 from account 1 and place it into account 2. And then we again print out the balances. Now, the runtime of this isn't all that exciting, but I will show you anyway. As you can see here, the account starts out as 5,000 for account 1, and account 2 has 10. And then after the transfer, 4,500 in account 1, and then 510 for account 2. Now this particular example would get much more interesting if we had several threads trying to perform transfers all at the same time, and you can pursue that on your own. Again, all it would change is we would have multiple threads all trying to access these accounts at the same time. Again, I was just trying to show you a simple example so you could see how the mutex works without making it overly complex, hiding the simplicity of the mutex class and things like wait all. There's also, if you were to look at the wait handle command or the wait handle class, you'll also have wait any, so it waits for any particular one to be acquired. You could signal and wait, which fires off a message to say that I am basically, signaling that I'm done working with this particular object, and then it waits for a given amount of time to reacquire, etc. So there are many different ways to accomplish that. Now, if you wanted to wait for a specific mutex and not a group, the mutex class has its own wait method, such as wait1, which allows you to wait for a particular mutex rather than a group of mutex objects. Now, the interesting thing about this wait handle, wait all is that it doesn't work just for mutex classes. There are many other thread synchronization classes that will also play with signaling with wait all. Things like the semaphore object will also allow you to wait on several objects at the same time as well. So you could actually mix and match mutex class objects with semaphore class objects. Basically, it has to implement the wait handle base class. And the three major classes that do that are mutex, semaphore, and event wait handle.